Right. Chalo. So we continue with laws of motion, and today we'll go by the third law, Newton's first law. We are done. Now we'll see some nice information. We're done with second law, and today we will be going for the third law. Before going to third law, again let us understand in first law and second law. First law is actually something that defines force. Second law quantifies force. Okay, quantifies force, and you get force is equal to uh, that is exactly not the definition. Rate of change of momentum is the right definition. Delta P over delta P, delta T. And from here, in your grade 9, you are keeping mass as constant. So you get mv minus u divided by T, which is equal to m into A. Okay? Third law, now all these things when they were studied, okay, if you see all these things, you are studying all these things with respect to something which is known as a body. If you recollect first law, you say a body at rest remains at rest and a body in motion continues to be in its uniform motion in a straight line unless and until a force acts on it. So force used to act on the body. Second law quantifies what is the force that is acting on the body. Third law will first time give the body the authority to also exert force. That's how you should learn it. Third law gives the body the authority to also exert a force. इतना देर तक बॉडी कोई फोर्स नहीं दे रहा था, बॉडी पे फोर्स एक्ट हो रहा था. There was a force which was acting on the body. Hey Aparna, switch on camera. Every day I won't say, otherwise I can't pick up. Yeah, what is use, leave the computer. That's just like a viewing window, or else I'll make it mandatory to come here. Your choice, pick up. So, because I can't shut the window of the camera, because in that case Sudriti suffers. Otherwise, I would have put the shutter of the camera down. Tit for tat. So, in third law, first time body will exert a force. Body will exert a force. Now, why body will exert a force? Again, same. They are all linked. We are all studying with respect to this force. This force is what is the force which is acting on the body. Now, let's understand. There is a force which acts on this body. Now, definitely, this force which acts on this body must have been exerted by what we call another body. Okay, this is our body, this is another body. This another body exerts the force, otherwise, force can't come, whatever it is. If you are pushing somebody, then I am that another body. Whom I am pushing, that is the body. So far, we were studying only about body, force acting on a body, force acting on a body. Who is acting that? Who is causing that force? Another body. So when we come to Newton's third law, the first thing that comes up is it should be a two-body system. First thing, knowing Newton's third law is very easy, but how to apply and identify a system, whether it is Newton's third law or not, that is very difficult. Even people cannot answer that after completing mechanical engineering, that whether this is a case of Newton's third law or not. It has to be a two-body system first. Right. The force which another body, let's say this is body 1 and this is body 2. The force which body 2 exerts on body 1, we will name this force as action force. Action. बहुत बहुत ध्यान से समझिए इसको. लोग गड़बड़ कर देते हैं. When you will go to 11th grade and you will do free body diagram, you will do blunder out of it. This is called action force. We will see that this body will also exert a force on this body. This force is known as reaction force. Okay. Now, things that you need to understand for third law to happen, third law to speak literature wise is the easiest thing. Every action has an equal and opposite reaction. That is literature wise. Going by physics, first thing you need to understand, it has to be a two body system. Second, there has to be mandatory, there has to be a action reaction pair. Action reaction pair, rather I would say, always exist in pair. If there is an action, there will be a reaction, and they always exist in pair. Whether you are able to identify or not, that's a different thing. They will always exist in pair, right? Two body system. Action reaction will be pair, and the most critical one, which will help you identify whether it's an action reaction or not, the most critical one, and that will be something like this, that we say nature of action and reaction will always be same. Now what do I mean by nature? Nature means if action is a friction force, reaction will also be a friction force. If action is a muscular force, reaction will also be a, if action is an electrostatic force, reaction will also be an electrostatic force. If action is a weight, reaction will also be a weight. As simple as that. You cannot say that my action was a frictional force and it's equal and the reaction is a magnetic force. No, no, no. ये तीन चीज आपको ढूंढना है. Once you find these two, not muscular, rather word I'll say a contact force. If you a contact muscular force or a friction force, will say, if these three things happen, then only Newton's third law is applicable. And I'll clearly show you one example where 100% you will say it's Newton's third law, but it's not Newton's third law, because one of them will be missing. But you bring any child from even engineering college and draw that diagram, he'll say Newton's third law. Even that diagram is there in your Lakshmi Singh. But Lakshmi Singh has very stylishly explained it. If you don't know the nitty-gritty of it, you will think, action reaction. So have you understood? Now we'll define what is Newton's third law. Newton's third law says that when a body, and in this case we are trying to mean our body number two. Okay. So, huh, exist in pair. They will be in pair. If there is an action, one reaction force is there. You have to hunt it. That's the issue. Okay. When a body, that's body number two, exerts a force on another body, that's in our case body number one. Don't get confused just because I wrote this as another body. Okay. If you get confused, then let me write this as another. This as another body, and let me make this as body so that there is no ambiguity now. When a body, and let me make this as body, or we can also call it as other body. Other body. Why other body? We'll see. When a body exerts a force on another body, okay, another body, the other body, that is one, or you write it, the body exerts an equal and opposite force on the first body. Don't write every action has an equal and opposite reaction. That's two. You'll make a blunder out of it. When a body, when a body exerts a force on another body, this body exerts an equal and opposite force on the other body. Further, we'll write on this, exerts a force, and this force is known as action force. This is known as action force. Exerts an equal and opposite force. This is known as reaction force. Known as reaction force. Okay? When a body exerts a force on another body, the other body exerts an equal and opposite force on the first body. First body means, try and understand, don't get goofed up between these two. This is a body, exerts a force on another body. This body exerts an equal and opposite force on the first body. That's this body. Okay? Don't get goofed up by 1 and 2. So let's make it more interesting now. So we say there are two bodies. Let's say this is body 1 and let's say this is body 2, just for understanding purpose. One exerts a force on this. One is exerting. This is body 1. This is body 2. One exerts a force on 2. So I call this as F12. F12, how to read it? Force exerted by 1 on 2. Right? We can write it here. F12 is force exerted by body 1 on body 2. Okay, body 1 on body 2. So this force will be known as my action force. Action force. So what does Newton's third law tell me? Newton's third law tells me that what nonsense is happening now today. Okay, this is known as my action force. So Newton's third law tells me there will be another force which is exerted by 2 on 1. We'll call this as F21. And F21 is my reaction force. F21, force exerted by 2 on 1, right? And this is my reaction force. So I'm writing them with vector symbol because they are vectors. Forces are vectors, okay? If you write without the arrow also at your level, it doesn't make any difference. This is my reaction. So if we want to bring it mathematically, what do we say? We say F12 is equal to F21. Is it correct? Pay attention. Is it correct? What is a force as a quantity? Vector quantity. You mean to say if this is 5 Newton, this is 5 Newton, direction won't be. Very good. This is negative of F21. So that when you bring it this side and you add it, it will become 0. Net force will become 0, right? Direction is different. F12 is a 2 Newton force on the western side. F21 is a 2 Newton force on the eastern side. Clear now? Now we'll see a lot of action reaction forces. And their examples. So what all we have to identify in action reaction? That there should be a two body system, mandatory. There should be an action reaction pair of force, and the action reaction pair of force must be same. The nature should be same. Okay? We'll see some examples of that before we go ahead with further problems. You don't exactly get problems of third law, but you'll get problems on momentum. So let's try and understand third law in more एग्जाम्पल मैनर. ठीक है, मिटाओ इसको यहां से. राइट, चलो अब देखते हैं. लेट्स सी सम लवली एग्जांपल्स where Newton's third law comes to play. Right. So let's suppose this is a bank of river from where the land starts. This is the land. Okay, this is the land, and your boat has just come almost to the shore. Okay. Now let's see how actually a person gets off the boat. You will find The person gets off the boat in this manner. We all get up from the boat. Now, if you see, if you think that this is body one, let's see the dynamics here. The person will first, how do you get out of the boat? You go like this. So you push the boat actually. You are pushing the boat this side. Contact force, frictional contact force. I push the boat. In other words, this is F12. The boat is my body 2. The body 2 will then exert an equal and opposite force F21. So you move forward. If the boat would have gone away, or the rack on which you are trying to push your leg, if that rack would have gone away and not offered you a force, you would not have come back. When we do push up, very nice example. Let's say a person does push up. In what manner? In this manner. How you are trying to do the push up? You are forcing on the ground. The ground equally forces you back. Otherwise, this is Newton's third law. This is your action force, ground pushes you back, reaction force, you get up. Two body system, action reaction pair will happen. In fact, one of the very nice example, this is one example. Then let's see the case of a rocket. How does a rocket propel? A rocket will have a lot of gases which will be coming out during its propulsion system. Its propulsion system will have ignition, and these gases will be exhausted at a very high velocity. So mass into velocity. The velocity is very high of these gases. So there is and in a very fraction of second, hydrogen will be burned. So delta T is very small. Momentum has suddenly changed. Lot of force. What is happening? The gas is exerting that force on the ground. The ground is giving that much of force. One of the finest example for this which I got, okay, they will give you scenarios and ask you to identify. One of the finest example. Let's see, before that example, let's see this one first. This you'll become more clear from the chapter of gravitation. Let's say this is our ground. Okay, this is our ground. And what we do, we put a block on this ground, right? This block will be, now this example becomes more clear after you go to the chapter of gravitation. So this block is actually kept on nothing but on planet Earth, and Earth attracts everything towards its center. So this block is being pulled from its center towards the center of the Earth. This is the weight of the block. Got it? Weight will always act from the center of gravity or the center of mass. We'll understand these things when we go in later chapter. Now, you will later understand. Now, what are the two bodies here? Can you identify? Earth and the box. Newton's third law says if a body Earth is exerting a force on body 2, then box should also exert a force on Earth. It should. Earth should also move towards the box. So there will be an equal pulling force. This is getting cancelled. This many people think that that is not true. The Earth is also being pulled. Why the Earth doesn't move, that we'll see later on in our next class. Okay. Earth is body number 1. This is body number 2. So this was a weight. This was also a weight. This is also a gravity. Weight is nothing but a gravitational force. This is also a gravitational force. So if this was Fg 1 minute, Fg12, this is Fg21. Yeah. We'll come to that. We come to that. So these two are cancelling each other, right? Now imagine, have you understood this part or not of Newton's third law? The Earth pulls the block also pulls the Earth. No doubt about that, with equal and opposite force. Later on, we'll see that why always the stone falls towards the Earth. Why doesn't the Earth go towards the stone? Yes, अभी तो होना चाहिए ना अगर pull कर रहा है वो अगले क्लास में देखेंगे. Otherwise, we'll deviate from here. Now, question comes: if this is kept on the ground, if this was kept on a piece of paper, the paper would have crushed, right? Now I keep a book on this table, the table is able to bear this book. इसके ऊपर एक हाथी रख देंगे तो table crash. So there is something which is known as normal reaction. Another force that comes into play, and normal reaction is a force. Normal reaction. Normal means perpendicular. Normal reaction. Normal reaction will always work where on the contact contact between two surfaces. Between two surfaces. Acha, where did the gravitational force act? On the center of gravity. Acha, what is the center of gravity? The center of gravity is actually the center of mass. Is it? Yeah. Where the entire mass of the system is thought to be concentrated. Very stylish definition. Let's take a cricket ball and assume that ball. See, in physics, we assume everything as point concepts, point concepts. If you take a cricket ball, then if you make it small, I can think it as a point mass. It's a point mass. How about an aeroplane? An aeroplane cannot be taken as a point mass. It's a big thing. And Newton's laws are all applicable for point masses. So we shift to a concept from whole body to a center of mass. Center of mass means the the point in the body where the entire mass is thought to be concentrated. Hypothetical. Let's take one aloo, potato, irregular shape. But you can find out where the aloo will be. Achha, how many of you have seen, if you will see this in higher taxis and all, they will have, there are two type of things that people hang on taxis in on the rear view mirror. One is eagle available. How many of you have seen that toy? I don't know. There will be a pylon on the desk. Many people have it on their houses, and there will be an eagle, and the eagle's beak will be exactly balancing. The eagle will not fall down. Have you seen this toy ever? Or somebody in their taxis have one Hanuman with Gada, and the Hanuman is exactly asa, horizontal. If you hang the Hanuman, then Hanuman should be like this. Why is Hanuman in this way? That is because the entire mass of Hanuman ka jo wo body hai na, it is not uniformly constructed. It's constructed in such a way that the portion where you tie the thread, the entire mass is there. Rest of the body is all halka. Therefore, when you pull it, are you trying to understand? Let me tie a thread here. ऐसा हो जाता है ना? But bring all the mass here, and here you make it absolutely light. Then it will ऐसा ही रहेगा. So that toy is there. I don't know. You have not seen. There's an eagle with both the wings spread, and there's a beak of the eagle. The beak of the eagle exactly rests, and people keep it on their study table. The study table will be like this, and the eagle will be exactly rotating. As a fan chalta hai, but the eagle doesn't fall down. That's because the entire mass of the eagle is on the beak. That's something, the concept of center of mass, where the entire mass. So these are, we are taking bodies which are symmetric in shape. A cricket ball, where is the center of gravity? Right at the center. But a potato, maybe you have to find out. Sir, how is the potato shape? The potato we got was something like this. So we will say out here is the center of mass. Somewhere. Not here. Getting it? Fair bit of idea. This is there in grade 11. So you need not bang your head now. So normal reaction will always occur on the contact between two surfaces. Where is the contact between the two surfaces? The contact between the two surfaces is here. So this is one pair of action reaction which have cancelled each other. There will be normal reaction. Means, why did the ground not crash inside? Because the ground has offered a normal reaction to this particular box. It's holding. And normal reaction is a limiting force. On this ground, if I would have put 3 army tanks, then the ground would have collapsed below. There's a limiting force. Similarly, like the ground is offering a normal reaction, the body will also offer a normal reaction downwards. These two are also what type of forces? Reaction forces. This is called a normal reaction. I'll call this as N12, I'll call this as N21. Why I am drawing this picture? Because how you will be shown in the book and other ways, they'll show you this diagram in this manner. They'll show you like this. How a book is balanced on a table. They'll show you, first of all, many books will draw the weight from here. This itself is a wrong diagram. Weight will never be acting from here. Weight will always act from the center of gravity, like this. They will show the weight, W. And they will also show a normal reaction here. They'll also show a normal reaction. Acid rocket dega. Normal reaction. And they will tell you, and half the children will say, this body is exerting this force and this body is exerting this force. Newton's third law. Newton's third law says both the action reaction should be of same nature. If this is a gravitational force as an action, the reaction is not gravitational force. So what is the exact explanation? The exact explanation is blues cancel blues, weights cancel weights, normal reaction cancel normal reaction. So what was missing in this picture? This picture was drawn only like this: W12 and N12 and W21. So you should see, this is W, this is N. This is not Newton's third law. Yeah. Let me just to tell one more thing and then I'll take your question. This is not Newton's third law because W is a different type of force. Normal reaction is a different type of force. W21 cannot be N12. Cannot be N12 to form a action reaction pair. So this is not, if they draw the diagram like this and they tell you that this is Newton's third law, no sir, this is not Newton's third law. Then can you explain this? This is the exact diagram. W12 is earth pulling. They did not, okay, the earth pulling. Then the body will also pull. That force they took it out. So what did they do? They actually omitted one of this force and they omitted one of this force. Okay? And they tried to show you a calm reaction force. That's it. You want me to explain this once again? I have no issues. I don't want to proceed further without you understanding. You got a basic level of idea. Let's understand this once again. Okay? Let's understand this once again. Now, since you know that there will be a reaction force, let's first understand what is normal reaction. Let's first understand what is normal reaction. Let us say there is a ladder like this, and on that somehow you have balanced what, a block of ice or something. What is normal reaction, sir? Normal to the contact surface. This is normal reaction. समझ में आया? Never draw it like this. ऐसे draw मत करो. ऐसे only weight occurs perpendicular in this way. This is normal reaction. Sir, our body was like this. Where is the normal reaction? This is the normal reaction. Follows Newton's third law. ठीक है? Now let's go back to our diagram and explain you once again. थोड़ा देखने में मुश्किल हो रहा है क्या? Let me draw from here. Right. This is a block. Let's see what are the forces acting. The best way to understand is first let's understand what are the forces. Since body 1 is in contact with body 2, so there will always be a contact surface. This is the contact surface. Clear? And now follow and ask me any question that you want. This means contact surface. This is the contact surface. Contact surface, and on contact surface you will have two forces acting. First, this body 1 will give a normal reaction to 2, N12, and this will all, normal means perpendicular, normal reaction acts always at the contact surface. Clear? Body 2 will give an equal and opposite reaction, N21. No, now we are not talking gravity at all. No, this is equal and opposite. Their nature are same. This is a reaction force. This is a reaction force. Any two bodies, when they come in contact with each other, there will, gravity acts when the body is being pulled by the earth. We could have had this system on Uranus also. Normal reaction exists. At that time, gravity won't be there. Normal reaction is a force. Whenever two bodies are in contact with each other, on the contact surface, there will be a normal reaction. Now apply Newton's third law out here. One body exerts a normal reaction on the other body. So the other body must exert an equal and opposite. That's Newton's third law. Are they of the same nature? Yes. Do they form an action reaction pair? Yes, they form an action reaction pair. So right here, this is, if you say that this is action, then this is reaction. Everything will become clear now. Same nature. This is you forget, you take this in space. Can you assume one thing? If a body is in contact with another body, okay, let me tell you like this. Don't ask these questions. Yeah, will I say no? First of all, have maturity. I'm explaining something. If you need water, will I tell you don't have water? It disturbs the flow. She's asking something. Out here, I am pressing this table. Has the table given off till now? No. Why? Why? The table is resisting my force. Do you understand? It has to resist, otherwise the table. Let me take one page out of here and put my hand. My hand goes down. The page is unable to resist. Okay, let's take one thing. Let's take look at that particular camera stand. We call it a cantilever, like a swimming pool diving board. Do you think you can sit on that particular white rack? What will happen? Gir jayega. Why? Because it can't give that much of reaction force to you. Can an ant be on that table? Happily. Can a sparrow be on that table? Happily. So the sparrow is in contact with that table. We are not talking about weight, mass, gravity, nothing. Whenever two bodies are in contact, this body is not going down because the other body is giving a reaction force to it. So when a body is in contact with body 2, there will always be a normal reaction. Do you get it? There is always a normal reaction. When a body is in contact with body 2, there is always a normal reaction. This is the normal reaction. So in that case, body 2, as per Newton's third law, should also exert a force on body 1. What does Newton's third law says? If you exert a body on one body, the other body should exert an equal and opposite force on you. So it's exerting. However, please understand, N21 has a limit. Right now we are identifying this as only one block. If this would have been 3 M21 Arjun tank, your N21 would not have been sufficient to hold it. Do you get the thing or not? Achha, how many of you have seen a crane, large cranes? Properly, a crane comes to lift a truck which has fallen off from the highway into the ditch. How will a crane lift the truck? Just first thing, crane should have this capacity more than that. That we all understand. Have you seen one thing? Have you ever seen crane lifting a heavy body? Lot of engineering is there. If you watch, the crane will first switch off its engine and the crane will protrude out two things which are known as outriggers. Outrigger means this is the body of the crane. Two pistons will open up and those pistons will go on the ground and first form the crane. If the crane itself is not firm, then halfway when it lifts the truck will topple the crane. Many examples are there on YouTube. And you see crane toppling while lifting load. Why all these things happen? Because when the crane lifts something, don't you think when you are lifting a bucket, can you lift a bucket on muddy soil? You will go down because the soil is not giving you sufficient reaction force. So if my crane has fallen onto the ditch, sorry, the truck has fallen onto the ditch and it's a heavy truck and a lot of rains are happening, the crane operator will immediately not lift that truck. वो बोलेगा आपको साहब confidence नहीं है, because the crane is unable to first form. If the crane does, nowadays cranes are all very highly technically very efficient. They will first calculate the force and tell you if the crane is not parked properly, the crane will never lift the truck. Ulta, what will happen? The truck will lift the crane. Now do you understand what is normal reaction? So the crane produces something which is known as outrigger, and the outrigger will have 4 columns and those columns will first go on the ground and they will first fasten the crane. Once crane has fastened, after that everything will happen. Even the army tank, when the army tank moves and you have to fire, at that time if there is a huge firing going on, the army tank will first, the amount of recoil that will happen, the tank itself, projection hi galat ho jayega. So understood. So now your question is, this is a body which is in contact with another body and this is the contact surface. Normal reaction always is normal on the contact surface. So the downward is the reaction force of 1 on 2. Have you understood? 1 gives a reaction force based on one's mass or whatever it can be. 2, in order for this to lie on this ground, 2 has to give a reaction force. If 2 is unable to give a reaction force, body will come down. Clear? Now you can also ask, sir, can 2 not give little bit more force that body will go up? This is a reaction force. I usually do not fight with you. If you fight with me, then only I react. My tendency is not to fight or offer any force. Just because you offered a force, I offered a reaction force. And there is a limit. I can fight with you, maybe I may not be able to fight with the other person. He may overpower me. So this is a limiting force. And within the limit, these two are balancing each other. Now, since this is balanced, so we say this one balances this. Now, the question arises, is this an example of Newton's third law? Exactly, this is an example of Newton's third law. We have two bodies, we have an action, we have a reaction, and both the nature of action reaction is same, both are reaction forces. And if you are unable to understand in this manner, Sanvi, then you can understand this way also. Say a hypothetical scenario is there where a block is on a vertical surface. This is the contact surface. There will be one reaction force this side, there will be one reaction force this side. Always. In mechanics, this has to happen. Understood? Action reaction, Newton's third law. Let us now see from the other side. Other side means now we'll see the gravitational force part also, okay, and see whether we have understood action reaction from gravity's perspective. Is this clear? Now let's take the same example. So many forces might be working. Now this is body 1, and right now as I'm no more interested on the contact surface, but this is my earth. Okay, this is the earth. Let's say this is earth. Here also let's say this is earth. So there is a reaction, action reaction also happening between body and earth. Now this is 1 and this is body 2. Earth will pull the body with a force of gravity from its center. This is called Fg21, force exerted by 2 on 1. This is what force? This is gravitational force. Gravitational force. Observe where it is acting. Observe where it was acting. समझ में आया? Gravitational force. In such a case, there should also be a force which the body is exerting on the earth. Understood? So from the center of the earth, we don't know where the center of the earth is, somewhere here, there should also be a force which this body is exerting. This is F12. Got it? Now applying algebra, this force cancels this force. They are equal and opposite. This force also cancels this force. They are equal and opposite. But the system is under the influence of two types of forces. F21 is also a gravitational force. This is also a gravitational force. This is also gravitational force. If this is action, then this is reaction. Now, how this diagram is shown in books? Usually it is shown in books in this manner. When they'll show this to you in books, they will show in this manner. See, they will have the ground drawn like this. They will have the body. This is the contact surface. They'll say this is the gravitational force. And mind you, since I'm drawing with a different color, I'm just drawing little bit offset. But this force arises from the center. They will say it is a normal reaction force, and they'll say both are the body is on the ground because these two forces are balancing each other. Newton's third law. No, this is not Newton's third law. Highly distracted हो तुम क्लास में, बहुत distracted हो. मेरी आंख जाती है बेटा, मैं कुछ बोलता नहीं हूँ, बात अलग है. First you didn't bring a pen, then you borrowed a pen, then you are sign language communicating with Vania by writing on the book which she is trying to read. कहाँ पे लिखा है वो भी मैं तुम्हें दिखा सकता हूँ. You're studying something new. Attention दो यहाँ पे. इससे क्या हो रहा है पता है? You get distracted, I don't mind. You are distracting her also, and you are equally distracting me. If I'm saying anything wrong, you can dispute with me. You had written something on the copy on this portion, explaining it to her. Yes or no? I have crossed your age. We have eaten tiffin also in front of the teacher without getting caught. So you are no match with me in all these gimmicks. But when something is being taught, at that time pay attention. Because you will be the first person who will tell me, I did not understand this. I have no problems. She did not understand, I'll explain it 5 hours in a row. But I'll not explain to somebody who does not take the pain to understand it. You are not taking the pain to understand. क्यों इतना डिस्ट्रैक्टेड होते हो? कभी लाइफ में सेल्फिश बनो, बी सेल्फिश समटाइम्स इन योर लाइफ. दिस 1 hour, try to study on your own. Upfront, I'm giving an example. I pulled you all. See, should I tell you? I'm not trying to differentiate. That boy goes and sits there. Have you observed Shaurya for last 2 or 3 days? अलग से जाके बैठ जाता है वो. इससे पहले क्लास में वो इधर आके बैठ गया था. जाने के टाइम आप सबके साथ जाता है, आते के टाइम आप सबसे आता है. पढ़ाई के टाइम पढ़ाई करो. आप वहां भी बैठ सकते हो, नीचे भी बैठ सकते हो, सुनने का इच्छा है कहीं से भी सुन सकते हो. What stops you from getting glued for 1 hour? In school also, maybe it may be thought equally good, not equally good, or better. But you have got 26 children also being taught at that time. हो सकता है chaos होता है. If there is a lacuna in me and you feel that no sir, the way you teach I can't see the board or anything, speak up. I don't mind. He also got up and came here. I did not say anything. Why did I tell you for that water purpose? That's an unnecessary query during the class. You need water, you get out. Will I ever say no? Before that, and why I told you in that way? Because before that, I saw you communicating on the book. तुम ऐसे लिख रहे हो और उसको बोल रहे हो ये something you communicated. So that has got hitched on my head. And I tell you, I get disturbed very quickly. And once I get disturbed, to get me back, it's dynamic equilibrium. Na, abhi aise, now I'll keep on rolling. Don't do that. और अगर ऐसा होता है, then see, option is today Aparna is attending online, not because she is an indisciplined kid. She has some obligation. You can also attend online. And in that case, I will say the reason is different because you are an indisciplined kid. आप घर पे ऑनलाइन अटेंड करो, कम से कम हम दो लोग तो डिस्टर्ब नहीं होंगे, एक तो उसको डिस्टर्ब कर रहे हो सकता है शी इज ऑल्सो इक्वली गेट्स डिस्टर्ब, एक मुझे डिस्टर्ब कर रहे हो, क्या फायदा इसका बोलो बेटा. और ये दिस इज नॉट अ चैरिटी क्लास दैट गोज ऑन. We also exchange messages with parents. You can, if sometimes I show you those messages, दुख होता है ना. If your dad, me, we are all maybe same age group, 2 साल 3 साल आगे पीछे, दुख नहीं होगा उनको. That जब बीच में communicate करता है तो complain से ही communicate. Is my son only like this? I also feel bad. Why should I write to somebody like a baby? So the diagram in a book, when you will see, they will draw this diagram like this. This is a gravitational force, and they'll say it is balanced by the normal reaction. And later on, whenever you will go and do any sort of diagram in physics, where a body, you will show a weight hanging downwards, you will also draw this diagram. There's nothing wrong in this diagram. In this diagram, what all we did not see, beta? We actually cancelled out this one and we cancelled. This is a downward force, this is an upward force. We just cancel these two. We did not draw these two. That does not mean those two are not there. When we go to say gravity or any other chapter, there whenever they'll say a block of wood is kept on a table, you yourself will draw these two forces. This is the weight of the body and this is the normal reaction R. Nothing wrong in it. Nothing wrong. But what is not correct is, don't say that this is following Newton's third law. That is what is wrong. So if I open your book, okay, if I open your book and I take the same example of action reaction, okay, first law, second law, and you see this diagram. This diagram is not exactly correct. Weight hanging downwards. The weight doesn't hang from here. The weight actually, now why did they show this gap? You know why they showed this gap? That's because this much part of the black is cancelling this much part of the red. Can I wipe them off? Lakshmi Singh is not wrong, but the explanation Lakshmi Singh gives is not sufficient for a 9th grader to understand why the diagram was drawn like this. Now do you understand? Look at the diagram, there's a gap. That gap is because you give me 5 rupees and I give you back 7 rupees. So how much I exactly gave you? 2 rupees. My 5 rupee part of 7 rupee cancelled the 5 rupee that I took from you. Correct? So exactly I am giving you 2 rupees back. That same thing is happening here. This is not an example of, this is nothing wrong in mechanics, but this cannot be cited as Newton's third law. Is this Newton's third law? Yes, sir. Is this Newton's third law? Yes, sir. Is this correct? Yes, sir. Is it an example of Newton's third law? No. In Newton's third law, action and reaction should be same type of force. What is this force? Gravitational force. What is this force? Normal reaction. A normal reaction cannot be the reaction of a gravitational action. Another example. Take a rifle in your hand and start firing, right? So the rifle, they say that you should be very firm with the rifle so that the rifle's the bar portion is out here on your shoulder. If the shoulder is tender, your aim will go out of out of the target because the rifle will recoil, right? So what is the rifle's recoil? Let us first understand. The bullet actually went out. Rifle has given a forward force to the bullet. The bullet exerts a reverse force on the rifle. That is one action reaction pair. Understood? Again, the rifle comes and hits back on your shoulder, contact force. So your shoulder will also give a force back on the rifle. That's why you hold it tight. Otherwise, nahi hota tha. Action reaction. This is action reaction. A truck goes and hits a truck, a Maruti 800 goes and hits a truck. Straight contact force, action. You will damage will happen on Maruti 800. That's different. That will study why the damage happens on Maruti 800. Because the Maruti 800's mass is less. But Maruti will also give an equal force on the truck. Damage will happen more to Maruti because that force will come back on Maruti itself. Say suppose a truck is staying idle, a truck is standing idle. A Maruti car goes and hits the truck. Who is causing the action? Maruti 800. What is the reaction? Truck will offer an equal and opposite force to the Maruti. What your eyes see is the damage on the Maruti. But who was the action creator? The Maruti itself. Who got affected by the reaction? The Maruti. But the reaction was not from Maruti. The reaction was set from the truck. Give a blow on this wall. Do you feel pain? Yes. This is action. Reaction came from the wall. Had I given the same blow to a sponge, is there pain? No, because the reaction is not coming from that side. But that doesn't mean they didn't give a reaction. They will give a reaction. But when they give a reaction, at that time, this force reduces sufficiently. समझ में आया Newton's third law? Let's revise once again. Newton's third law says when a body exerts a force on another body, the other body will always exert an equal and opposite force on the first body. That means for Newton's third law to happen, two body systems should be there. First of all, one body will exert a force called the action force. The other body will exert an equal and opposite force. Look at there. If this is downward, this is upward. Equal and opposite. Equal and opposite. So I will, to make it more interesting, let's write the equations. Here it will be like this. N12 will be equal to negative of N21. These two are equal. And out here, it will be what? Fg21 will be equal to negative of Fg12. This is there. Now let's look at this diagram. Right now these two are equal. But is it Fn N212? No, this much portion is gone. This much portion. The normal reaction need not be equal to this. But out here when we are showing the equilibrium, we have actually cancelled the in between part of both. So this force right now, the red force that you see is not N21. It's a little bit lesser than N21. And this force is not exactly the weight. It's a little bit less. But बीच में खा चुका है. Do you understand? So if this diagram is shown to you, this is not Newton's third law. Newton's third law is always equal and opposite. Now one fine example. This I got when I was teaching a student at IB in US. I mean, nothing can be a better. Can I have this off? Nothing can be a better example than this. Okay, let's see this example. So this is very interesting. If you want, I'll send you the soft part also. This is the outer part of Earth, and there is somewhere the International Space Station is here. Okay, ISS, the International Space Station is here. So let's say this is the International Space Station, and this is your space shuttle. This is your space shuttle. This is the shuttle. This is the space shuttle. Some problem has happened to this space shuttle. Don't you? I think you all know the astronauts come out to space. They come out to space with oxygen and everything loaded on them. Okay, it's come out to space and he is repairing something out here. Okay, he's repairing something out here. Now, he is at some particular distance, say S from this particular space station. And the problem says that the type of tools that he has got in his hand, he also is carrying a hammer in his hand to repair something out here. And the oxygen is depleting badly. He has oxygen worth some 2 minutes or something left in him, before which he should now at least go inside the space station again and put up a new cylinder and come out. But he suddenly is a little bit far away. Means if he goes by the normal gravitational float, his oxygen will finish. What should the astronaut do at that time? Yeah. Releases oxygen tank, oxygen, because then he will not have oxygen. He has oxygen which is worth some 2 to 3 minutes there, but it is on a red alert to him. What he should do? He should throw his hammer out from his hand. Once he throws the hammer will exert a equal and opposite force on him, which will propel him to come this side. And that force says, I actually truncated the question to you. The question there was how with what force he should throw the hammer. With what force he should throw the hammer. So that force is equal to what? That force should be equal to mass into acceleration, his entire combined mass and the acceleration. We don't know what is the acceleration. What is his initial velocity? U. So you know S is equal to ut plus half at square. See how much mechanics is employed. Ut plus this t is a time which is less than, it should be oxygen khatam hone se pehle usko ghusna hai. Say suppose he is having oxygen worth 3 minutes left with him. That's how much? 180 seconds. So he will take this t with a factor of safety, say 150 or 100 seconds. If I am at his place, I'll take 100 seconds. So that the acceleration comes more. Are you getting it? What I'm trying to do? If you invite me and I eat 3 puris, you will try to make 5 puris. Kaun ek zyada mang liya to? So in 180 seconds, my oxygen will be finished. So in 180 seconds, I should go here. I will take that as 100 seconds. So I will get my initial velocity 0. I know how much distance I'm there from the planet or space station. So I get my acceleration. Once I get my acceleration, I know my combined mass. F is equal to ma. With that force, if I throw the hammer, I move inside. Beautiful explanation of science. Our NCRT books don't give this. And what she said is also correct. But her answer goes a little bit wrong. Why? Because if he releases the oxygen, he doesn't survive. He's going inside because the oxygen is depleting. If you have more. So the problem scenario is an astronaut is repairing something on the outer space from the International Space Station, and now suddenly feels that his oxygen level is depleting and he has worth 3 minutes more of oxygen left with him. So within 3 minutes he should get inside this space station, right? So we will do our calculation not with 3 minutes, we will take as say 100 seconds only. So using that we get our value of A. Once we get our value of A, we know our combined mass, and then we should know with what Newton. Now if you release the hammer, a body exerts a force on the second body. Who is the first body? Me. Who is the second body? Hammer. The second body exerts an equal and opposite force on the first body, and you go inside. Now you will be an idiot if you throw the hammer this side. Then you go more far away from the planet. There you go. Right? Because the reaction force, this is the beauty. This is what physics is all about. See, if you throw it this side, the reaction force occurs in the opposite side. I bet in schools and all, they don't want to involve you in these discussions. But if you throw it on this side, the reaction force happens on this side. Yeah, so then he goes more far away. Then he's lost in space. Interstellar हो गया वो, कुछ नहीं कर सकते. मजा आया ये प्रॉब्लम डिस्कस करके. अभी आपका I have the entire write-up. I'll give you this entire write-up. So the idea is, we had a 1 hour discussion. School में 10 मिनट पढ़ाएगा. What equals this, then children, this is the example, these are the questions. नहीं, ये मजा लो physics का. तभी तो आपको love बढ़ेगा subject के लिए. So normal reaction, in Newton's third law, we will always have two bodies. and the two bodies will have an action and a reaction. Action reaction is not with one body. One body will give an action, the other body will give a reaction. An action reaction should be same type. If the nucleus pulls the electrons are also pulling the nucleus. Got it? Always it has to happen. That is Newton's third law. That thing has to happen. If there is a magnetic force, don't you think there are two magnets, magnet A, magnet B? You feel that only A pulls B. B is also pulling A. So when you propose somebody Vivan and you think that I am proposing, I am only attracted, Newton says the other person should also be attracted. Now don't try to do that, otherwise stilettos might come on your face, because Newton's laws applies to only particle physics. Our sir also says, in our class we used to say like that. So sir, if I like somebody and I say I have an attraction, does she also have an attraction? Sir said it is applicable for particle matter. Don't try that. No, I'm giving a real life example. That's what I gave you that example also. That if you see somebody beautiful on the bus stand, do you see attraction? That, oh, that will give you when we study gravitation. We'll have that example. We'll do a calculation basically, and we'll try to show you that all this infatuation does not work. Physics will prove that. Okay? Is Newton's third law clear? Right. एक लास्ट टॉपिक जस्ट इंट्रोड्यूस करके छोड़ेंगे. Once you have understood Newton's third law. Newton's third law does not have numericals. Numericals will be on conservation of momentum. ठीक है? Newton's third law does not have numericals. Only second law has numericals. But conservation of momentum you will understand properly if you have understood this part. So once again I am saying, nothing hiding. If there is anything doubt on this, please ask now. Because after this, all the problems will be a truck collides with a car, a bullet fired from a rifle. ऐसा type problem होगा. There, people solve it in two ways. One is रट्टू. है इसमें अच्छा ट्रक था ना, इधर था ना, इसको -2 लेना था, उसको +1 लेना था. 0 हो जाएगा फिर. Understood this thing clearly? चलो थोड़ा सा मोमेंटम को रिविजिट करेंगे अभी, एंड देन आपको छोड़ देंगे. डोंट वरी. ओके, मेरे को तो टेम्पो आ जाता है. देन आई कैन टीच दिस फॉर नेक्स्ट 2 hours also. I don't mind, but by that time you all will puke. Okay, let's go back to momentum. And what you are studying right now, though your book doesn't mention at grade 9, this is linear momentum only. Linear momentum is anything that is happening on one plane, not angular momentum. There's something called angular momentum. We are studying linear momentum, just for your knowledge. Okay, momentum. What is momentum? A vector quantity P given by the vector product of mass and velocity, m into v. Right? So the law that we're going to study is conservation of momentum. What is conservation of energy? Can anyone tell me what is energy conservation? Sir, do not burn the light, do not burn. No. What is law of energy conservation? Come tell me, you all must have studied this. Energy conservation law means what? Yeah. Conservation of energy means energy can neither be created nor be destroyed. Energy is always converted from one form to the other. The whole universe's energy is always constant. Do you know that? चलो आज इतना टाइम नहीं, आज कुछ इंटरेस्टिंग बता के छोड़ते हैं. Look, there is always a dispute नहीं, interaction between these two things, matter and energy. Okay, this is what is Einstein's rule. Something नया कुछ सीखते हैं फिजिक्स में, इसको छोड़ दो अभी. If you can bring all the energy of the universe and compact them in one place, you actually make matter. That is matter. हाँ, एनर्जी को एक जगह पे लाने से मैटर होता है. And matter, if distributed in the speed of light, becomes energy. That is what is the Einstein's famous equation of E equal to mc square, where c is the speed of light, m is the mass, and E is energy. Okay, that means if we go back to times of, say, Mahabharat wars and all, right? And whatever I'm going to tell you, you're going to laugh first, but then you'll straight away take back your laugh. Huh? See the beauty. In Mahabharata times, they say that a bloody battle was fought in Kurukshetra for 18 days, and they say lot of weapons of the order of maybe nuclear weapons were used. Like what is Brahmastra? That is nothing but a nuclear weapon was used. Now, all those masses, all those weapons have got converted into various forms of energy. If you can convert that energy back to mass, you should be able to see that weapon once again in your lifetime. Okay, na? So let's understand one more thing. Suppose we go back to, let's go back to that's what I'm asking, I'm saying, let's go back to 1600s. And we are in the court of Akbar, the Mughal emperor. And Akbar, when he used to be free and wants to have leisure time, he used to call upon Tansen. Do you know who is Tansen? One of the Navratnas of his court, who was a singer. Tansen was the creator of all rags, and used to say, Tansen ko bulawa bhejiye, gaiye rag so and so. They used to say Tansen, when he sings a rag Malhari, the rains used to come. So Tansen used to sing. Somehow we have sent Shaurya on time travel to Akbar's court. Okay. And he watches this, that whenever Japana is angry, Japana calls Tansen and says, कुछ मेरे लिए गाना फरमाइए. शौर्य देन सो सेड, ये बार बार तानसेन को क्यों डिस्टर्ब करता है, आप एक ना MP3 गाना रख लीजिए ना इनका, और हेडफोन डाल लीजिए, जब चाहे सुनेंगे. By that time, Akbar thought that is an insult to the king and ordered that let his head be chopped off. Okay, as a thing. But come to today's world. Is Kishore Kumar alive? No. Is Michael Jackson alive? No. Don't we hear them? We hear them. We hear them. So don't we think that we should be able to recreate those phases? You know what is in earlier days they say an angel or a god could actually vanish from here and immediately come in front of you and say, so be it, my son, when they hallow and go back. That is nothing wrong. When a person travels faster than the speed of light, he is time traveling. The fastest thing that travels in our time is what? Light. If you can travel faster than light, then I should be right now at my home also. Imagine that concept. That's time travel. Very interesting things. This is a star. The name of the star is Proxima Centauri. Because if you all don't study this, you will not understand the beauty of it. This is Earth. This star is the nearest star to Earth, also named as Alpha Centauri. The distance of this star is 4.21 light years. Light years. Now, what is 4.21 light years? Let's understand. Distance traveled by light in 1 year. Distance is speed into time. So let's find out what is the speed of light. Speed of light is 3,80,000. Okay, 3,80,000. So that's 3,80,000 kilometer, means in meter, 3 more. This is the speed of light per second. Distance traveled by light in 1 year. 1 year has how many days? 365. Each day has 24 hours into 60 minutes into 60 seconds. You can imagine what is this distance coming out. And this distance is coming out in meters. Divide this by 1,000. Divide this by 1,000. So we get is kilometers. So many kilometers away this star is. That is the nearest star to you. Now, let us understand the definition of 4.21 light years. What is the date today, beta? 10th, 7, 23. Tonight, the star's light that you see actually left this on 11/7/2019. That is the light you are seeing for today night. This is the nearest star. There are much far away stars. Maybe the star which you are seeing today, it does not actually exist and it's already gone. I am seeing Sanvi right now. Is it a live telecast? No, there is still a delay. Light is traveling from our body and hitting my eyes. You don't believe it? Okay, let's start a match on Tata Sky and on Hotstar parallelly. You will find the Hotstar feed is slightly delayed. If 5 people are watching it on Tata Sky and the catch has been taken, yeah, you'll hear in your neighbor's house and then you'll say, yay, out, because it comes little bit delayed to you. In fact, in our childhood, what we used to do, the Prime Minister addresses the nation from the Rajpath, from the Lal Killa on 15th August. So that you tune on AIR, All India Radio, and you tune it on Doordarshan. Doordarshan is a faster signal. So there he will say, in our days, Rajiv Gandhi was the Prime Minister. Bharat ki Janta ko, after some time the radio says. That was my interest. I never used to hear that lecture, but I used to make sure I'll switch on both to see. And in radio also, there used to be a medium wave and a short wave. So I used to take one more radio and put it on short wave. First, Doordarshan will say, then short wave will say, then medium wave will say. This is the love for science. Not I'm boasting. ये ऐसे चीजों को देखो. So the star light that you're going to see tonight actually left the star on 2019. So some stars which you're seeing do not exist at all.